Hello and welcome to ICND2 Lab 5, EIGRP Configuration and Operation. For those of you with the Cisco Press exam certification guides, note that the material covered in this video matches the material explained in ICND2's Chapter 10. This lab has three main objectives. By watching this lab, you should be better able to configure the EIGRP network command, in particular the two variations on this command. You should know how to confirm on which interfaces EIGRP has been enabled on a router, and you should have a good idea of how to interpret the output of the show IP route command, particularly when variable length subnet masking is used. This lab uses two scenario steps to meet these objectives. In the first step, you'll see how to configure EIGRP in a network that uses only subnets of Class B network 172.22.0.0. The second step, you'll discover the impact of when a router configuration does not match all its interfaces, in particular, how that router does not advertise about the subnets off those interfaces that aren't matched. So let's go ahead and start step 1 by looking at the topology used in this lab. This lab uses three routers, R1, R2, and R3, each connected by a point-to-point serial link using the interfaces and addresses shown there on the screen. Each router also uses one of its fast Ethernet interfaces, namely FA0/0, with the IP addresses you see here, 172.22.11.1 off router 1, 12.202 off router 2, and 13.103 off router 3. Also, to show off the fact that EIGRP is a classless routing protocol, thereby supporting variable length subnet masking, this topology uses four different subnet masks in this single Class B network. The serial links, it uses a mask of 255, 255, 255.252, or in prefix notation, a /30 mask. Each of the three LAN subnets uses a different mask, with a /25 prefix length being used off router 1, a /26 prefix length off router 2, and a /27 prefix length in the subnet off of router 3. Keeping track of the different subnet numbers and ranges of IP addresses implied by those subnets can be a bit difficult when using variable length subnet masking as we're using in this lab. So the booklet has a copy of the figure that you see now that lists all 6 subnets and their prefixes. The booklet also includes a table that not only lists the subnet numbers, but it also lists the range of valid IP addresses. To configure EIGRP in any network, you'll use the router EIGRP command followed by one or more network commands. Now the EIGRP network command has two basic styles. In the first style that you see here, there's a network command followed by a Class A, B, or C network number. Now this network command works just like the RIP network command because it tells EIGRP to do EIGRP on every interface on that router that's in that classful A, B, or C network. Now, doing EIGRP means sending EIGRP messages out each matched interface, listening for EIGRP messages coming in that interface, and advertising about the subnet connected to each of those interfaces. The second style of EIGRP network command is very similar to the first, but with the addition of a wildcard mask. The wildcard mask concept works exactly like the OSPF wildcard mask in that it limits which interfaces are matched by the network command. So a router with this style of network command compares the address listed in the command to each interface, but only for the parts of the address as dictated by the wildcard mask. For example, take a look at router 1 here with 3 interfaces, each of which of course have an IP address. The configuration on R1 would require the router EIGRP command followed by the autonomous system number. Now this shows an autonomous system number of 1. The only real requirement though is that this number be the same on all the neighboring routers that want to exchange routes with EIGRP. So unlike OSPF, this number does indeed need to match amongst the various routers. Then you'll have one or more network commands. Here we've got the network 172.22.11.0 command with a wildcard mask of 30.255. Now if you look at the 3 interfaces, only the fast Ethernet 00 interface matches that network command, so R1 starts, quote, doing EIGRP on that interface. It sends EIGRP messages out the interface as shown there with the red arrow, but it also listens for incoming messages and advertises about that subnet. Then if router 1's configuration is updated to include the network 172.22.112.0 command, with a wildcard mask of 30.255. That command would match the S010 interface on R1 because the first 3 octets of the IP address on that interface match the first 3 octets of the address in the network command. So R1 would start sending and receiving EIGRP messages and advertising about that subnet. Now let's move to the command line interface and configure EIGRP. R2 starts with working EIGRP configuration that covers all three interfaces, so we'll start here with router 1. First we'll use the configure terminal command to get into configuration mode, and then we'll use the router EIGRP1 command that you see there to enter EIGRP configuration mode. All three routers will need to use the same AS number 1, by the way. And as usual, notice the command prompt changes to show us we're in configuration mode, as shown there. On R1, we'll use the older style of network command that does not use a wildcard mask, so just type the network 172.22.0.0 command and press enter. Now this command tells the router to look at all of its interfaces in network 172.22.0.0, and that's all three of its working interfaces. So we've just enabled EIGRP on all three interfaces on router R1. To verify that EIGRP is enabled on all three of those interfaces, we need to use a different command than we used with RIP. So if we do the show IP EIGRP1, one referencing the AS number, interfaces command, look at the output, notice we see one line for each of the three interfaces, FA00, serial 010, and serial 011. So this is a confirmation that that network command did indeed enable EIGRP on all three interfaces. Next, let's move over to R3 and configure it. On R3, we'll use the style of network command that uses a wildcard mask just to show some alternatives. So we use the router EIGRP1 configuration command, which moves us to EIGRP configuration mode, and then we'll try the network command. In this case, we'll do 172.22.113.0 with a 0.0.0.255 wildcard mask and press enter as you see there. Now that means any interface that begins 172.22.113 will be matched. Now as it turns out, that matches serial 011, which is connected to router 1, and as you see there, we've already got a message that popped up that said that we've got a neighbor relationship now on the other end of serial 011 in this message, and that happens to be router 1. Next we'll do another network command to match the other serial interface, network 172.22.123.0, with the same wildcard mask. Now that command will match the other serial interface, serial 010, so R3 will supply a message saying that we've now got a neighbor relationship on the other end of serial 010. Now we'll get out of configuration mode and do the show IP EIGRP1 command with the interfaces option as you see here. And this command again will show the interfaces on which EIGRP is enabled on R3. Notice it just lists the two serial interfaces. However, in this case you may be tempted to think that you've fully configured EIGRP because now R3 is enabled on both interfaces connected to other routers. There are no routers on router 3's LAN interface. Step 2 of this lab takes a closer look at that problem. Notice here on router 3, both serial interfaces highlighted there have EIGRP enabled, and router 3 has started to exchange routes with both R1 and R2. However, R3 doesn't have any routers on its LAN, so you might think that R3 doesn't need to talk to any routers out there. However, the subnet number that you see there, 172.22.13.96 with a /27 prefix, won't be advertised by R3 because R3 doesn't match its fast Ethernet interface. So at this step, we'll take a look at that problem, and along the way, we'll take a look at how to interpret the output of the show IP route command. Before examining the problem, let's just take a look at the simple output of the show IP route command here on router 1. First of all, notice there are several routes, in this case 2 routes with a D in the left-hand side of the route, as you see there. Now look at the legend. D refers to EIGRP learned routes. It turns out when EIGRP was created, the letter E was already used for an old routing protocol called EGP, so Cisco had to use another letter, so they chose D. Now if you look at the top line of this output after the legend, it says network 172.22.0.0 with a /16 mask, in other words the whole class B network, is variably subnetted. Now that means we're using VLSM. For instance, if you look out toward the end of that same line, it says 3 different masks are known inside this one class B network. So that's proof that we're using VLSM in this case. It also says that we know about 5 different subnets of this class B network. Now focus on the highlighted route shown on the screen. It's an EIGRP learned route to 172.22.12.192, which is the LAN-based subnet off of router 2. Now because VLSM is in use, the mask needs to be shown with each route or each subnet because the mask could be different in each case. So notice here we have the /26 mask for that subnet shown at the end of the routing table entry. Now consider the problem again. Notice there at the top of R1's show IP route command output, it lists 5 subnets. Well, of course, there are 6 subnets in the topology here, and that's because R3 is not advertising about its LAN-based subnet. So, if we switch back over to router 3 and get into configuration mode with the configure terminal command, get back into EIGRP configuration mode with the router EIGRP1 command that you see there, then we can type another network command to match that LAN interface. So in this case, we'll try network 172.22.13.0 with a 0.0.0.255 wildcard mask. Now in this case, that matches all interfaces whose first 3 octets are 172.22.13, which does indeed include router 3's LAN interface. So after configuring that command, if we switch back up to router 1 and do a show IP route command again, right off the bat we can look at the top line after the legend and see that it lists 6 subnets with 4 different masks now, which is proof that at least some route was learned. And if you look at the very last route in the routing table there, you see 172.22.13.96 with a /27 mask, which is indeed router 3's LAN-based subnet. In this lab, you've seen how to configure the EIGRP network command, in particular 2 different styles of the command. You've also seen how to confirm on which interfaces a router has enabled EIGRP, and you've seen how to interpret the output of the show IP route command, particularly understand the details that are shown when VLSM is used.